Boring, huh? So you're supposed to collect what? You're supposed to have independent variable and then dependent variable, is it? Yeah, you're supposed to have one of each. But I don't have it set up, so I wouldn't know what your values are. You know what I mean? Yeah, lah, but I wouldn't have the data. Let me look at your equation first. So so oh, you have the data. You have the data here. Can you screenshot and send me the? Oh wait, hold on. What's this? Oh, I1, I2, I average. Wow. Okay. I1, I2, I average. Okay. So the length and the current, right? So basically you're supposed to, okay, hang on, wait, I need you to screenshot that for me. Okay, so your situation is that you have the what EMF, okay, equals to I rho L over A, okay, right? They make it look cheap, but actually it's V equals to IR. You understand that? Okay lah, but we're not here to look like, you know, make fun of the equation. Okay, so but they did say that they want you to change L and they want you to measure I, correct? So am I right to say that your L is your independent variable? This is your independent variable, and this one is your dependent variable. Okay, and then did they give you look at the instructions on the what you call it, the procedure? Did they tell you exactly what else do they want you to put in? There's only one L. There should be more. Confirm will tell you what you're talking about. Different values. Can you flip over? Can you flip over one page? Is there a table there? Okay, so the different values of L are all there. But is that the answer? Is that the answer? That's the answer, what? That's the answer. Okay. Anyway, don't worry. I think is your Excel open? Yeah lah, your Excel must be open lah. Open your Excel, right? Because we are doing Excel now. So we are going to collect data. Okay, and there's the independent variable. All right. Am I right to say that our job is to what? Plot a graph, is it? We need to plot a graph, is it? Okay. So you would notice that the I and the L are on the same side of the equation. So it's a bit weird to plot a graph like that. So you may have to rearrange it. But I think ultimately we need to find out what do they want us to find. Do they want us to find EMF for the battery or what? Huh? What? You don't know? Okay. Look at the instructions, or read the questions at the start. What does it say? They say what? In this experiment, the electrical circuit is set up to find what? So they want to find rho over area. What a strange thing to find. Okay, right? So they want us to find rho over area. I mean, that's what we need to find now, right? So we'll find it. But I think, right, there is one thing that you need to make sure of. If your rho over A is something that you're supposed to find from the experiment, then you need to have EMF values. So are you given the EMF value? Did they mention that the EMF value is a certain value somewhere? I would think so. We probably will have to be lah, huh? Is what? 2 volts, It's 2 volts. Okay, so that's what the experiment is saying is 2 volts. Okay, good. But then this equation doesn't really look plottable yet. You see, I don't even want to touch the Excel data until I manipulate this equation, no? So how should I manipulate it in order for me to plot it? So I guess I have to bring the I somewhere, right? And maybe the V somewhere. I don't know. If I bring the it looks a bit what? So they want L as a subject, is it? No. No, you shouldn't put L as a subject. It's very weird. It's very weird. So you know what I'm gonna do? I'm gonna tell you that it looks like this. V over I is equals to rho A times L. Do you see that I rearranged it like that? Okay. Um, maybe I will rearrange it again. I rearrange it to I 1 over I is equals to 1 over V rho A L. Like that. I think I may rearrange it like this. Your independent variable should be on the your independent variable is which axis? X or Y axis? It should be on the X axis. Yes. Your independent variable is on the X axis. Okay? Independent variable should be on the X axis. And so in a way this is your Y axis. Okay? So if you look at it, then you will realize that you will have y equals to half rho over A times X. Kind of like this is like y equals to mx, right? So which means that if you plot the y value over the x value, you should get a straight line that passes through origin and that the gradient is equals to half of rho A. Because the voltage is 2, right? You told me the voltage is 2, right? Like the question itself, right? This is 2 volts, right? Okay. Yeah. So this would mean what it means. That means that if I were to plot but that means I cannot plot I versus L, you know. I must plot 1 over I against L. Did they not say that? Or they said it something else, some other way? Yeah, lah, yeah, correct lah, right? Yeah. So you see, right, before you even do the table, right, this is what you need to do first. You need to rearrange it such that it gives you a general formula, then you can start plotting. Check. Wait, what are your concerns? What do you mean you can't do that? You can't do that. What are you talking about? What? No, you can't do it. What are you talking about? No, you can do it. I give you another one. Okay, I give you pendulum. What nonsense? Write this down. What do you mean 15 minutes to do what? To do what? Grafting? This what you mean even to plot the thing, to key in the numbers to plot the thing, everything only 15 minutes? To do the experiment and collect the data also? Cannot. These kind of things I explain very slowly, but you know when you need to do it, you need to do it very fast lah. Okay, I give you one. T equals to 2 pi square root, right? L over G. I tell you that L is your independent variable, right? And T is your dependent variable. Okay? And I say that I want to find G. How should you plot this? Wrong. Okay? Right, like that only wrong. Yeah, you are. Okay. Right, you cannot think too simply on these kind of things, okay? Right. So the fact of the matter is 1G, right? But T and L are not directly proportional to each other. You know, they're not directly proportional to each other. They have a square root there. Correct? So what we want to do is maybe to make things easier. Okay, one way is you can plot T versus square root L if you want. Right? But you have to plot it against square root L. But if you want, okay, let me do one version. So one version is this. You do T equals to 2 pi over square root G, then square root L. This is in the format of y equals to mx. Do you see that? In the format of y equals to mx. Okay? So what are you supposed to plot then? Then you're supposed to plot T versus square root L, right? T versus square root L, and then the gradient is 2 pi over square root G. That means once you get the gradient of your graph, you're supposed to back calculate and get G from that gradient. Okay? So this is method number one. You can do this. It means you plot, all right? Plot t against, all right, square root of L. But you see, right, you're in your table, right? In your table, you would have collected L, you would have collected L, you would have collected T, right? That means you have T1, T2 some more, right? And then T average, right? Correct or not? But then once you find T average ready, you still have to go and create another column called one, like square root of L. Then you plot the T against square root L. Like your job is to create that column there with the square root of L. And you have to do that in Excel, which I'll show you in a while. The next one will be T squared equals to 4 pi squared over G times L. So the other method is you plot T squared, right, versus L, right? So if you plot T squared versus L, the gradient of your graph, y equals to mx, the gradient is 4 pi squared over G. You still have to go and extract the gradient out. Okay on this? Can I? Okay. Right. I'll show you how to type in I'll show you how to type in the formula for square root inside the Excel later. I show you how to type in the square for the Excel later, right? I just show you how to do the cell, but you basically have to create these columns. Can? Ready? Okay. Let's do this now. Right. Okay. So back to your equation. Back to your sample. Right, hang on. Back to your example here. Right, back to your example. We're supposed to plot what? What was your example again? Sorry, your example back here again was what? I'm supposed to plot I over 1 over I against L, right? So I need to have my independent variable first. So I need to put L on this axis here, like this. Okay. Usually I prefer to center 0. Yeah, I zoom in a bit. Okay. Sorry, I like to put the center, the alignment to center so that I don't get confused. So I like to put L there. And usually they want you to put it in slash headers. They must have proper headers, right? Slash in the units that you're supposed to use. Like, which is what? Is it in cm or meters? Meters. The answer is meters. Yes, meters. Okay. In meters, right? So usually I like to present it like this. Can? Right. Then what's the first length that you have? You said 0.4, is it? 0.01. That means 10 cm. 10 cm? Correct or not? 10 cm? I thought you said 0.04 just now. The table is 0.01, is it? Okay, so so that means that you're supposed to come up with your own numbers. So those numbers there, you're supposed to come up with it yourself. Right? So 0.01, right? Okay. Now you see, if you key it in like this, you're going to lose marks. Because a meter rule can measure up to 1 mm. Okay? Right? You can measure up to 1 mm. Right? So 0.01 is 1 cm. Sorry. Is 1 cm? Are you sure? Okay, it's 1 cm, right? That's 1 cm. Correct or not? Okay? If you key in like this, right, you're going to lose marks. Okay? Because the meter rule is supposed to measure up to the 1 mm mark, which means that you need to put a 0 at the back. Okay, but you see, Excel has this peculiar thing. You see, I put 0 at the back. I press enter. Oi, where has it gone to, right? They're going to take away marks for your wrong significant figures. Right? Say how? Okay? So what you need to do is you need to adjust the decimal. So you need to click this thing here. You click on it, it should appear. Yeah, Excel is not working. I don't quite understand. So you have 1 cm, 2 cm, 3 cm, 4 cm, 5 cm. Okay, I don't know how many cms is there. Is it not working? Okay, okay. Give you some time. Work it out. Work out the kinks and the bugs. Can? You confirm you can type in this number first and you can adjust the decimal first. You press that one, right? You see what happens if I press more? So if you use a vernier caliper, it should look like this. Right? But because it's a ruler, it's like that. Understand? What's the next number? 0.03, huh? What's after that? 0.05. Okay? So you see, right? What you can do is, after you key it in a few, and how many data points do you have? Up to what? 0.099. Okay. 0.099. Okay, so anyway, you have to just basically make sure that all of them are 3 dBs, like that. 135799? Is it even 7? Sorry, what? I couldn't hear you. 0.090 and then 0.099. Okay. Okay. If let's say you're on a cell and you want to edit the number, what you can do is you can also press F2. Do you have F2? If you press F2, you can edit the cell. Do you have an F2? Huh? Yeah, you have an F2. Yeah. If you press F2, you can go into the cell and can edit it like that. Okay? So you can press enter, then the thing will go down. If you press tab, tab goes to the right. So tab goes right, enter goes down. Tap, tap, enter, tap, tap, enter, tap, tap, enter, like that. Okay? Into the next row. Okay, anyway, you say 0.099, right? Okay. So that's your first row of data. You got to learn how to play with the decimal places. Okay. What's the next one? T, no, I1. I1, then I2, is it? Then I average, is it? Right? And all of them are in amperes. So I press F2, I slash A, go to the next cell, press F2 slash A, go to the next cell, F2 slash A, like this. Right? This is when you want to quick edit. Right? These are a little bit of the shortcuts. Okay? Now you have to do the arduous task of reading to me all the currents. Boring numbers. Okay, hang on. What happens if this one was 1.30? You see that? Okay? Then do you realize that that's not quite right? What do you have to do? Adjust the decimals again, because all of them supposed to, according to your instrument, is supposed to have 2 decimal places. Okay? But it was not 1.30, so 1.29. Okay, come, next one. Mm-hmm. Mm-hmm. Uh-huh. Uh-huh. Okay. Then the average, right? The average values, look carefully. Excel is powerful because of the formulas. So you can key in a formula here. You see this fx here? Fx means function, right? You can key in a formula here. So you can key in equals to, you can press the equal sign. You press equal, so you basically start with equal, right? Then you type the word average. And you open bracket. Okay? And this is what I like to do. Now you can use your mouse to go and highlight these 2 cells. You can click and highlight these 2 cells. But the way I like to do it is like this. I hold down shift, right? I hold shift and I press left 2 times. Left. I press the left arrow 2 times. Then it will auto select the 2 left cells for me. Then I close bracket. Then I press enter. or what? Equals to average of this cell and this cell. Why is that cyclic? No, cyclic. Okay, can? So, yeah, average of, sorry, not, did I make a mistake? Equals to average of, oh, I will press left one time, then I shift and I press left again. Sorry. Yeah, too troublesome, then you do this, average, open bracket, then you just use your mouse and then you just highlight the two cells. Like that, here, okay? Then you can enter. Okay, so far? Can, Now what you can do next is you can copy and paste this cell. You can copy, you see it? You can copy, Control C this one, and then you drag the other cells and you paste over. Yeah, copy and paste. Or if you want, right, you select the corner of this cell. Do you see the corner? Once I selected, my cross becomes like that. Then I drag it down like this. Right? So these are the shortcuts. Can? Okay. But you have to make sure that all of them are the same DP. So since your what call that? Your current the raw data is in 2DP, then we will just leave it as 2DP like that. So you need to adjust the decimals again. Right? Otherwise you get weird decimals, right? Like just now. Like it was looking like that. So you need to adjust it. So you reduce it to 2DPs. Yeah, so follow SF. So now because the requirement is that we need to do a 1 over I. So we need to take so this is 1 over I average. Okay? So this is equals to, we'll put a 1 equal to number 1 slash, then I click the cell. Understand? Then I hit enter. Then after that, click and drag everything down. Then don't have to calculate anymore. That's why it's only 15 minutes. Yes, okay. But here's the thing. So since it's a 1 over I average, you have to round this off to 3 SF because your original number here has 3 significant figures. It's confusing, I know, but the rule is this, okay? Your average was calculated based on these two currents. These two currents have 2 decimal places. So we will just leave the average current as 2 decimal places. But when we do 1 over I average, okay, it is no longer like in relation to this anymore, right? Not directly related anymore. Okay, so it becomes a division rule. So the division rule is this: whatever value you get at the end must follow the same sig fig as your original data, which is 3 significant figures. So I round this all to 3 SF. Okay, so I play with the decimals, 3 SF. Okay, now before I go any further, just in case I didn't catch it, I didn't manage to, right? What you want to do is, if let's say you need to square root this number, you equals SQRT, open bracket, click the number, close bracket, that's the square root of the number. Okay, if you need to square, then you equals to, like this, equal to this cell. You see, once I click the cell, it will show me the cell arrange the cell marker, and then I put arrow up to the power of 2. That's square. Okay, can? But we don't need to do that now, because what we need to do is we need to plot the graph already. Because right now I have L, and I have 1 over I average. Okay, now to make life faster and easier, the way you select the cells next is going to be very important. Okay, all right. So which one's supposed to be on the x-axis? L. Because L is your independent variable. Independent variables are supposed to be on the x-axis. Yeah, it says L against, but the L is supposed to be the independent variable. It has to be on the x-axis. Yes. You go and double check. Okay? I'm pretty sure I've done this many years. He may have forgotten or something like that. Just make sure that you can go and Google this up. Independent variable is L. Shouldn't the independent variable be on the x-axis? Okay. Anyway, what I'm going to do, I'm going to select these values here, and I'm going to plot it against these values here. This will be on the y-axis. This one will be on the x-axis. The order of which you select the cells will make the graph come out faster. Okay, so I select this one first. You select the X first. So I click and drag this. Okay. Pinky finger on control. Okay, can be any other finger. Hold down control. Hold down control. Select these cells. So now you're able to select two. You just what? Just undo. Control Z. Okay, one more time. Okay. So I select this ones first. Then pinky finger, I hold down control and I select the next row. I don't know. Okay. Hang on. Because your one might be command. Because Mac user. Yeah. So it also depends on what laptop I'm gonna give you, no? That will make your life a bit faster lah. Okay? Okay, so one more time, you try. Okay. So I select this one, then you hold down command and you click this other row. Correct? Okay, good. Alright. With these two columns, nothing else in between selected. So the most dangerous one will be if you accidentally go and select all of them like that. Then you try to insert the graph, you're gonna get in trouble. Okay, so you select this one and you select this one. Okay, then you go to insert. You click on insert. You click on the charts. Don't click the wrong thing. You click on this one called the scatter. Don't go and draw the one with the line. I don't want the line. You don't want the line. Just click on the one says scatter. Click on scatter. This is your graph. Understand this? This is your graph. Okay. I don't like the axis. Okay. But the thing is, if the graph is not marked, then you don't have to bother. But I personally like to still adjust this. So I'll double click on the y-axis. This is damn extra work. Double click on the y-axis. You see the thing pop up over there? Right? I will make the minimum 0.5. Right? So that the graph looks a bit nicer to scale. But that means that the graph starts at 0.5. Can? But I don't know whether you actually need to do this lah. Okay. Okay, can have you adjusted already? Okay, now you click on any one of the data points, you click on it, you realize that it highlights all your data points. Correct? Right click. Right click. Add trend line. You see the graph? By default, it will always try to give you a linear fit. By right, yours is supposed to be a linear fit, so we just leave it as linear. If you have any other graphs, that's another time, another day. When you go to IB, you will deal with that when you do your IA, right? Be it chem or physics, right? They will be the same one. Linear graph, Okay, last magic thing. Scroll down on that formatting window there. Scroll down, scroll down, scroll down. You see this one? Display equation. Okay? Then you see this equation here. Wait, wait, I want to make it a bit bigger. The gradient is 2.7419. The y-intercept is supposed to be 0. It's supposed to be 0. Because by theory, the equation is supposed to be 0, right? So basically, you have what we call a systematic error. Okay. Now this one, the next thing so this part here, I'm not too sure. Some teachers may say that, oh, you're supposed to use the origin as one of your data points, right? So they may say that, can you force the y-intercept to be 0? I don't think that's correct. If your teacher says that, that's not right. Okay. Anyway, this is the y-intercept. It's supposed to be 0, but it's not 0. So there's some error inside. Okay. Doesn't matter. Your data points also a little bit scattered. So look at that. Right. What you need to do now. Yeah. Let me just double check. Is my length correct? Yeah, my length is here correct. Is my I over 1 over I average correct on the y-axis? Yeah, that's correct. Okay. So the gradient here is 2.749, right? Okay, can. Now, you're done. Once you can extract this gradient, you're done with the Excel already. Yeah. Okay, wait, hang on. Let me just show you this. So this the y equals to mx, the theoretical y equals to mx, is supposed the m is equals to 2.7419. What did we say again? We were trying to plot this, right? Okay? Right. 1 over I equals to 1 over V rho A L. 1 over I, this is my y-axis, right, which is this one here, equals to 1 over 2 rho A, then L, right? L is my x-axis. So, I mean, it's correct what? Right? If you want me to find rho over A, the most logical thing to do is to plot 1 over I against L. Not the other way around. If you plot it the other way around, right, you're inversing the entire equation, no? Then the gradient will not give you rho over A. The gradient will give you A over rho. Then you invert it again. That's a bit silly, right? The L should be the independent variable. It should be on the x-axis, which is the case here. Okay, so right now my 2.7419 is equals to the half rho A. Right, so the 2.7419 is equals to the half rho over A. So which means my rho over A will be equals to 2 times 2.7419. Then I think you can get your answer somewhere there already. Can? Right, if you know how to do this, then okay lah. Next time you can go out to work already. Yeah, I find it a bit weird lah, asking, huh? Yeah, like that lah. Ratio of rho over A lah. That means they want you to find the resistivity against area. Yeah, which is that value there lor. Whichever. Huh, sorry? Why is the what so big? So you need to present these calculations there. Yeah, you need to extract, because once you're done with Excel already, you need to extract the gradient. Then you must say that from the graph, from the plotted graph, gradient is 2.7419. Then you calculate the rho over A from there. But you have 2 times 2 lah. Can okay? Alright. I hope this is the way that they want you to do it lah. Because like I'm showing you a lot of shortcuts, you see. I'm showing you a lot of like things that, okay, so I suspect some of the teachers may even do weird things like this. Okay? Because my JC students are also doing this now. Like it's part of their national exams, the A-level exams, that they have to go to practical, sit and use a laptop to record data like this. Right? So I suspect some teachers will yeah. some teachers will say something like, oh, you're supposed to go inside here, then you're supposed to right click, then select data, and then change the data from here, like this, right? They must add the data, X values is this, right? Then Y values is this, something like that. Right? I suspect some teachers will teach it like that. Like, yeah. For me, I don't like it like this. I mean, my data is there already, right? For me, it's just kind of like, I highlight this row, this column, I hold on control, highlight the other column, and then I just insert the chart based on these two columns. X-axis. So it depends on which column you highlight first. So if I highlighted this column first, then I highlight the other one, right? If I highlight this, then I highlight that, right? Then I go and insert. I think if I'm not wrong, my memory serves me right. Eh? The heck? Oh, then maybe it's the order of it. That means I put my data on the leftmost side one. That one is the x-axis. Yeah. Oh yeah, I always thought that if it's dependent on the way I highlighted it. No, it's not. It's dependent on how it's ordered inside here. So if my L values are behind here, right? Then I select these two columns, right? Then I go and insert the thing. Then the axis will be swapped the other way around. So yeah lah. The ones on the x-axis should be on that side there. Then the y-axis should be here. Yeah. I think some teachers will then tell students that, oh, okay, you are supposed to copy this column, paste somewhere, then copy this column, then paste somewhere, then highlight the two of them, and then plot like that. I think that was, yeah. Oh, is it? Yeah, no matter lah. Okay. So yeah, it's supposed to be done like that, lor. If you go to school and you are being instructed some other way, can you let me know? Because at least I sort of know what style they like lah. Okay, Google Sheets is the same. It's just Google Sheets a bit slower. So Google needs to send the data back and forth, right? And if your Wi-Fi is spotty, like sometimes you click one number, right? You have to wait for a while for the number to be registered inside. So you cannot type Google too fast. That's why I love to use Excel. For so the thing is this, I do this data thing for all of my IB students. Like once they get the raw data, like what you showed me just now, right? I say, okay, you don't do anything else. You let me process your data for you. You let me draw the graph for you. Then I say you can start writing the report. Which is why, I mean, in a way, you see just now the chem teacher was complaining, right? How come last minute then show me the data, then the data is wrong, submission is tomorrow, then she's not very happy and all that. For me, I know I will end up like that. I know if I let the students do it their way, confirm will make a big gigantic mess of it one. And then if I have to go and rectify, because maybe the parents say like, please help my son. Then I got one whole jing gang of them, 15, 20 of them asking me like, oh please, the day before submission, can you fix my data for me? Oh no way, man! Like that is physically impossible for me to help. That's why I from the start, right? I say that the moment you finish your lab, you come out with the data, you don't do anything else. You immediately go and show me your data. You go on a Zoom consult with me. You show me your data. I will draw the graph for you because I want to make 110% sure that there's no mistake with the graph. The problem is the report, right, that they write, is based on the graph. And if there's any mistakes in the graph, right, whatever you write has to change. You know what I'm saying? So the student go and do one wrong graph, they go and write all the analysis based on that graph, right? Then afterwards I say, hey, your graph is wrong. Habis, I correct the graph already, they have to go and rewrite the whole damn thing again at the bottom. So I tell I think since 2018, I tell the student, forget it. Let me just do it my way. Right? Yeah, let me just do it my way. Okay lah, a bit sway because there have been students who come to me like at the start of year 6 specifically for this service, and then afterwards they go somewhere else because all their friends are having fun somewhere else. So I get very annoyed by this kind, because I know actually it's quite silly because the worst thing is that at the end of the day, right, they go to those places, actually they don't get like even proper help. Those places refuse to help them with IAs. Yeah. And then they go to those places, then they end up the teaching there is also not proper one. So it's like I don't mind helping if it comes to a greater good. But I help you, right? But you go back to trash, right? Then I help you for what? You know what I mean? I make it look nice for you, I make it good for you, but you decide to go back to being a piece of trash. Then what's the point? I like this like so. I get very fed up with this kind. Yeah, I I I totally don't mind if you tell me like it's really far and all that kind of things. Like you need to find some other help. You need to find a private tutor and all that. I'm like, I got this kind of cases. Well, that's fine. That's none of my business. Like whether or not you need a private tutor or not. But the worst is they come to me and then they go to the trash places. Then it's like, Allah, don't dirty my work. You know, don't dirty my work. My work is, I know the things I do for my students you cannot find outside one. Yeah, guarantee you cannot find outside.